Hello friends, and welcome back. So, we are in the 5th week of this course water supply engineering, and from this week over next 2-3 weeks we will be talking about water quality and its treatment. So, this particular week we will be focusing more about the basics of water quality and what is the philosophy of water treatment, particularly for the urban water supply system, and then subsequently in later couple of weeks we will be talking about more advanced treatment or procedures. So, this class will be discussing on water quality and water pollutants, and what we are going to cover is about the quality of water, then how water quality varies as per source and what are the various sources of water pollution. Then we will be talking about the natures and types of water pollutants, what are the routes of exposure for these water pollutants, and what are the acute and chronic pollution effects we will be covering in this particular lecture. So, to begin with, as we discussed earlier also, let us get back again to the basic right to water as has been adopted by United Nations. So, this human right to water entitles everyone without any discrimination to the sufficient, safe, acceptable, physically accessible and affordable water. Okay. So, there are 5 aspects which needs to be satisfied. The water should be made available in the sufficient quantity, in the safe condition, in the acceptable condition, it should be physically accessible and it should be economically affordable. Okay. So, we did discuss about the quantity aspect of water availability, how we estimate the demand, which is more so about the adequacy in terms of the quantity or the sufficientness of the water. Now, what we are going to discuss is about the other 2 aspects, which is safe and acceptable. Both of these are in some way or other related to the quality of water. Okay. Safe essentially means it should be safe to consume. Okay. So, it should not contain any such substance which can impart any harm or any toxicity to the consumer. So, that is the safe. Okay. So, there should not be toxic chemicals, there should not be microbials which can actually lead to some disease. So, like the waterborne diseases typically what we say. So, the water should be safe from these kind of pollutants which can have adverse effect on the consumer, and it should be acceptable, means that the water which is given to us, it may be chemically or biologically safe, but if it is say a colored water, if it is say a water which is having some apparently visible turbidity or sediments, so that water is straight away not considered acceptable for drinking purpose. Okay. Somebody would not like to drink a water which is having certain color, that color may be perfectly safe. Okay. We do use lot of food colors, okay, in food or other items, and those colors are safe to consume, but if somebody asks for a glass of water and he is given a water which is having certain color, he will be immediately skeptical what is inside this water. Okay. You can drink a colored juice or soft drink or other thing, but when you are just going to drink water, plain water, you would like to have this as its natural condition, which is more or less colorless. Okay. So, acceptability in that term. So, the safe and acceptable are more or less related to the quality of water, which we will be discussing in this week. So, while quantity of the supplied water should ensure the quality of the supplied water should ensure the public health safety, that means essentially free of disease causing microbes and chemicals, the water abstracted from the source may not be of usable quality directly. The water that we have in our river, lake these days, it is not of that quality which we can directly drink. Okay. So, in order to make this water suitable or good enough for the consumption, we need to improvise its quality, which is usually done through providing treatment. Okay. Further, the objective of a municipal water supply system typically is to provide water which meets the drinking water standards which are set up by the different regulatory authorities. So, like in India we have BIS, Bureau of Indian Standards, they give us drinking water standards, and the water which is supplied should ideally meet those standards. Similarly, there are different standards for different nations, and there are certain international standards also, which we will be discussing in later classes of this week. So, as source water generally do not meet these drinking water quality standards, we need treatment of water for making it good enough or for improvising it so that it can meet these drinking water quality standards before it is supplied to the consumers. Now, when we talk about the quality of water, like you see here, there are a couple of water bodies. One is looking pretty clean here, and another is looking pretty dirty. So, just by apparently viewing these, one can say that okay, this certainly has lot of problem, this may or may not have that much of problem, that is secondary point, but ideally by viewing itself you can say that the quality of water in these two different sources are different. Okay, that is quite apparent just by seeing these images, one can say that. Okay. So, similarly the different water sources may have different quality of water. It is just two surface sources, but if you take a surface source or a groundwater source or two different surface sources or two different groundwater sources, you do not expect the same quality of water lying in all these sources. Okay. So, we may actually be dealing with different quality of water when we tap the different sources, and many times the nature of the pollutants are characteristically different when we tap the different sources. The pollutants available in groundwater may be totally different than that available in the surface waters. Surface waters more likely to have more of the sediments and other things. Groundwater may have some other type of chemical, maybe geogenic contaminants, arsenic, fluoride, these are more popular groundwater contaminants. So, depending on the source of water, we may have different characteristic of the water. Now, when we talk about the improvement of quality, we are essentially talking about the removal of the pollutants present in the water. So, from where these pollutants come in the water, there are various sources of water pollution. Okay. These pollutants may come from the variety of sources originally in the water, and these sources may broadly be classified into the point sources and non-point sources. So, non-point source of pollution, when we discuss, so non-point source of pollution essentially means the pollutant entering in the water is not, the point at which the pollutant enters in the water is not fixed. Okay. So, it is basically diffused or dispersed source, like you say the agricultural runoff. So, when you irrigate agricultural field, you can see several small drains or patches from where water leaks through and may go into the river, or urban runoff for that matter, atmospheric deposition. So, along with the rain, when the pollutants are getting deposited, so they are not coming at one specific particular point, rather they are dispersed and distributed over an area. So, these type of sources are called non-point sources of pollution, whereas the point sources of pollution are the one which are more specific and which are introduced at one particular point. Like if you are having an industry, so industry is discharging water. So, after all this process, there is a final point through which industry releases its wastewater or its effluent. So, the release point of the industrial effluent is fixed. So, you can call that as a point source. Similarly, for let us say the sewer lines are collecting the sewerage of the entire city and then bringing it to a treatment facility. So, either fully or partially treated sewage is again being released to the to a river or lake or a water body. Now this also, like when it is released from a sewage treatment facility or STP, it is released at one single point. So the discharge of an STP is a point source. Okay. The image that you see here, like this oil spill coming from a oil tanker, is actually a point source, is specifically being released at one point. So these are some of the examples of point sources, while as we discussed there are many non-point sources. Now there are in fact a variety of point sources as well as non-point sources which may contribute the various types of pollutants to the water. Okay. So like we can get pollutants coming from the agricultural sources, coming from the industrial sources, coming from the municipal sources, coming from the natural sources, okay, and the nature and characteristic of these pollutants also varies substantially. So if we see the nature and type of the water pollutants, we can classify them or categorize them on the basis of different aspects. So if we categorize them on the basis of source, so we can have industrial pollutants. So industrial pollutants are the pollutants which are being released from industries. Okay, it could be anything. There are mostly the chemicals, in fact. So variety of chemicals, you know that there are industries for everything. So during their process manufacturing, they use variety of chemicals, and those chemicals are released back into the environment and in the water bodies, leading to lot of industrial pollutants in the water. Okay. Our major rivers are all susceptible to these pollutants, like in Ganga there is several places where this industrial effluent goes in the river Ganga. Okay. Now say the tanneries or all those industries, leather industries in the Kanpur, which release the waste in the Ganga downstream the Kanpur, but by the time water reaches to Allahabad or Prayag, it is abstracted, the water is abstracted at Prayag for say domestic or for say municipal supply purpose. So the contaminants released downstream the Kanpur may travel to that point, and when you abstract water, you will see those industrial contaminants present in the water which is being abstracted for the municipal supply. Okay. So that way these industrial pollutants may come into the water which is to be treated and supplied, and if treatment is not adequate, they may actually end up going to the consumer's tap, okay, and eventually entering into the food chain of the consumers. So that kind of risk is always there. So the industrial pollutants are mostly chemicals, and it could be actually variety of chemicals depending on the process of the industry. So like if you are talking about textiles, so there is lot of dye, phenols, those things comes from the textile industries. If you talk about the distilleries, so lot of sugar, fatty acids, these things come. Okay. Lignin, tannin also comes. Then the leather industry releases, they use chromium, so some compounds of like chromium based compounds or those things may also being released, very high COD. So variety of chemicals may come in the form of industrial pollutants. Similarly, the agricultural pollutants, these are again predominantly agrochemicals. Okay. So the fertilizers, the pesticides may even again when it is applied to the agricultural field after event of rainfall or excessive irrigation, these may find their way to the water bodies, or these may in fact lead to the groundwater, from where if you pump water you will see that kind of things coming into the water. So that way agricultural pollutants are also toxic chemicals many times, particularly if we talk about the pesticides. Okay, or it may be nutrient rich water like nitrogen and phosphorus compounds. Agricultural pollutants also could be sand, not that much of sand but silt, and because a lot of sediment washout also happens. so they may add lot of suspended silt and those kind of materials as well. Then urban pollutants, the sewage that we release from our household. So, some of we release lot of pollutants in that, some are treated in the STP, some may not be treated in the STP and eventually finds their way. And then there are natural pollutants which is very difficult to control. So, geogenic or biogenic pollutants and quite a few of groundwater contaminants, including say various heavy metals, iron, arsenic, then other elements like fluoride, then nitrate. So, some radioactive compounds as well may come from the natural sources. So, these natural sources, geogenic or biogenic pollutants are the one which are introduced by the natural processes. Okay. So, based on these sources we may have variety of pollutants, and it is not that one pollutant will be actually exclusive in one category. Say an example of pest repellent, okay, which is which may be used in a agricultural field, which may be used in a household. So, it may come in a agricultural pollutants, the same compound or same composition of the chemical may come in the urban pollutants as well, and may actually come in the industrial pollutants also, because it is being eventually produced in an industry. So, the waste released by that industry producing say pesticides will be having pesticides in the industrial pollutants. When those pesticides are applied on the agricultural field, so agricultural runoff is going to have that pesticides in the agricultural pollutants, and the same compound or some of its fraction may be used in some urban setups as well for gardening or for pest repellent in the households. So, then it may come in a urban pollutants as well. So, that way we can have different type and different type of pollutants based on from where they are coming into the water. So, what is the source of those pollutant? Similarly, we can have different class of pollutants based on their physical and chemical property. So, there might be physical pollutants generally which has a physical attribute. So, like color, you can see that, okay. Then the sediments you can see those sediments coming into that, okay. So, these kind of pollutants which have physical attributes are essentially physical pollutants. Then chemical pollutants are any chemicals present in the water, and biological pollutants are the microbial pollutants present. So, virus, bacteria, fungi, those kind of things present in the water, cryptosporidium, giardia, those things will actually be coming in the class of biological pollutants. Chemical pollutants are variety of organic and inorganic chemicals which may be there in the water, and as we said that we can have a physical pollutants in the form of sediments, turbidity or such things. Then the pollutants may be classified based on their nature of degradation, okay. So, moreover particularly the chemical pollutants may be degradable or non-degradable nature, okay. So, the degradable nature of the pollutant are the one which gets decomposed in the natural systems by virtue of chemical or biochemical reactions, okay. So, like if you have a organic matter, let us say sugar or those kind of thing, if you sucrose, glucose, if these things are there in the water, you leave that water for some period, and the microbes, if microbes are present in the water, they will decompose or degrade that, okay. Or some such compounds may actually take part in the chemical decomposition itself through hydrolysis or through oxidation, photooxidation, those kind of thing, and may get degraded in the water itself. So, these compounds are called degradable pollutants because they get decomposed or degraded in the water, okay. Majority of the organic matter are of this nature. These are also known as non-conservative pollutant because they cannot conserve their mass. So, they get decomposed into the smaller products, okay. If you have a compound A, so A will get converted to B plus C or some other smaller byproducts, and the compound A will not remain as A in the water. So, that is not able to conserve its mass, okay. So, A may get converted to B, which may eventually get converted to C or D, C plus D, then this may be converted to E. So, we may have a chain or which is basically a pathway kind of thing. So, when you are monitoring A, so at any time say t is equal to 0, you monitored some concentration A0, but as the time progress the concentration of this will keep on decreasing. That means it is this compound A is not able to conserve its mass. So, that is why it is called non-conservative pollutant or degradable pollutant, because it may get degraded or decomposed in the medium. These pollutants are also called reactive pollutants because they take part in the reaction and as a result get decomposed of. Whereas, the opposite of these are non-degradable pollutant, which are also known as conservative or non-reactive pollutant. Non-reactive as in they will not take part in these chemical reactions. So, they are not going to take part, means if it is A, it is not going to take part in the reaction. So, A will remain as A only and it will conserve its entire mass, and that is why they are called conservative pollutant or non-degradable pollutant, because they do not get degraded in the medium. So, if a pollutant which is coming into the water medium and getting decomposed, and this decomposition actually could be to a complete scale of mineralization, means generally organic matters are made of C, H, O, may have N, P, other things as well, but C, H, O are the main constituents, and then after complete mineralization they may get into the products like CO2, H2O, those kind of products, okay, may have N2 or this kind of thing. So, eventually like this is not a contaminant, this will escape to the atmosphere, okay. So, we are not getting any toxic effect more or less out of these kind of when something is getting decomposed to these level, except release of CO2, which is a greenhouse gas, okay. But water has become free of these compound more or less, okay. So, that kind of compounds which easily gets degraded in the water are not a major threat as a water pollutant, because they will get decomposed or degraded in the system, although the time may be high or low. So, again we may need to explore that in more greater detail, that even if it is degraded, how much time it is taking to get degraded. While non-conservative, while the conservative pollutants are more of a threat, because let us say if you are having arsenic in the water, okay, or iron in the water, or certain pesticides which is not taking part at all in any reaction in the water. So, this is going to remain in the water itself, okay. It may be convert to arsenic 3 to 4, arsenic 3 to arsenic 5 or iron 2 to iron 3. So, the form conversion may be possible, but overall total arsenic or total iron more or less is going to remain present in the water until unless they are removed by some other mechanism, because natural reactions, natural decomposition reactions will not remove these compounds, okay. Or if you are having a antibiotic or say pesticides which is not possibly will get degraded by the microorganisms, then it may actually remain in the system for much larger period, okay, because it will not react with anything, it is a non-reactive compound or non-degradable compound. So, it is going to conserve its mass, and they are major threat because they are not easy, it is very difficult to remove these compound from the water, okay. And moreover natural process does not work for removal of these, and we have to rely on the alternate systems. So, that way we can classify the pollutants from different aspects, okay. Now, if you see the major types of water pollution, more common water pollution, okay. So, we may have pharmaceuticals coming in water, fluoride is coming, pesticides coming, pathogens, metals, dyes. So, these are some of the common water pollutants which may be there in the water, okay. If you classify them type wise, so this is one such list. Actually it is not a comprehensive list though, we can have a few more types, but it is just kind of still an attempt to classify some of the pollutants. So, we may have a biodegradable waste, okay, which the sources will be runoff or this kind of things, and then this is the symptoms and this is the effect of such pollution. We may have nutrients, which is primarily nitrates and phosphates. We may have heat, which may increase the temperature, then sedimentation related pollutants, so basically suspended matters. Then there might be chemicals which are toxic and hazardous chemicals, they may come from the different sources including industries. There are radioactive pollutants, okay, which may come from the industries or hospitals or factories, or from geogenic sources as well, from mines or natural sources, and they add radioactive isotopes to the system. Then we from medical sources we may have medicines, antibiotics, then microbial sources we may have bacteria, virus, protozoa, those kind of thing, okay, and they also may come from the different sources. So that way we can have different classes of water. This is another list of the common water pollutants and their different sources. So like you see, there are pathogenic organisms, there are solid waste might be coming, degradable organic matters, there are chlorinated hydrocarbon which are organopesticides, there are biphenyls, detergents, dye stuff, phenol, inorganic acid, lead, cadmium, various metals. So there is possibility of different kind of waste coming into the water, okay, and from what sources they come and what kind of distribution they have in the environment, particularly the water environment. Okay. So once these sources are once these pollutants are released in the water, okay, they may enter our food chain, or they may affect us, they may affect humans by certain routes of exposure. So the common route of exposure for environmental pollutants are inhalation, ingestion, then dermal route. These are the major three routes through which pollutants through which basically we get exposed to these pollutants, okay. There is another like transfer across placenta. So basically a woman transferring these pollutants to the baby, okay, while giving the birth. So that is another route through which by birth itself someone can be acquiring certain type of contaminants, but again we consider that as a minor route. The major route through which one gets exposed are inhalation, ingestion and the dermal route. Now inhalation is important for air pollutants only, because we do not inhale water. Inhalation may be an important route for aquatic animals for water pollution, because they inhale in the water. So it may be basically of some value to them, but for humans this route does not apply for water pollutants, it is prevalent for air pollutants only, okay. But the ingestion and the dermal route are the major routes through which we get exposed to the pollutants. So typically it will be either ingestion or dermal. Now ingestion or oral route basically is effective when we consume contaminated water directly. So either we through our oral route, either we drink contaminated water directly, or we prepared food items using these contaminated waters and then end up consuming that. So then also the water is actually, or the contaminants in the water is entering our food chain, while the dermal or skin route which can result skin contact with the contaminated water during the bathing. So when we are taking the bath or washing or swimming, so these kind of things may actually lead to the contamination to the exposure with these contaminants, okay. Whereas inhalation route is not important, and the transfer across placenta also plays just a minor role. So once we get exposed to these pollutants, they may have different kind of effects on us, and two major classes of effects are based on two different type of exposure, and they are acute and chronic exposure. So acute exposure is basically a short term exposure of relatively high level of contaminant. So when we get exposed to a high level of contaminant for a short period, and as a result we see the symptoms arising in a pretty quick time not necessarily means as in like in a minute or in an hour, but even if it is happening in a few days, we will consider that as an acute exposure, okay, and acute effect. So, it is something like we get contaminated with something at any time, we get exposed with at any time, and in a very short span of time we get effect of that. So, like for example, if you drink a water which is say 3-4 days old or has some microbial growth in that, so if there are pathogens in the water, you consume that water, you will get fever in, say, maybe if you consume in the morning, by evening or by next day you will be starting getting symptoms of the fever, dysentery or those kind of effect. Okay. So, majority of the epidemic or what we call the waterborne diseases are the example of acute effect. As one gets into the contact of these contaminated waters, okay, these effects prevalent and sort of they will appear in relatively shorter span of time. Whereas chronic effects are generally the result of long term exposure, okay, of relatively low level of contaminants. Okay. So, for example, like we know that there are issues related to fluoride in the groundwater, arsenic in the groundwater, or various like antibiotics present in the water which are not treated properly. There are pesticides present in the water at many places, and people are drinking that water, people are consuming that water. And if you drink a water which is say having a fluoride level of say 2 or 3 milligram per liter, whereas the prescribed limit of the fluoride maximum is around 1 milligram per liter. So, maximum permissible to 1.5 though. So, if you consume that kind of water which is having fluoride more than that, or you consume a water which is having some ppb or some ppm of the pesticides, okay, which you should which is not permitted, it is not that you drink that water and you will immediately fall sick. Okay. People have been consuming those for years and years. It is like smoking a cigarette. Cigarette smoking is considered injurious to health, but it does not matter that it is not like that you consume one cigarette and you will immediately fall sick. So, it takes time, it takes time in the years actually. It may require 10 year, 15 year, 20 year to apparently show some effect. So, same with the water pollutants. If you are drinking say fluoride or arsenic or some pesticide contaminated water on a regular basis for over a period of 5 years, 10 years, 15, 20 years, then what you may apparently develop is that it is getting accumulated slowly in your body, and it reaches a level where it can actually damage an organ, it can lead to some cancerous effect. Okay. So, the chronic effects will that way not be noticed immediately. Okay. It may take a long time for detecting these chronic effects, okay, but once it is detected, because the nature of the effect could be cancer, could be chronic observatory pulmonary diseases, neurological problems. So, the nature is such serious effects that it is very hard to rectify, it is very difficult to reverse those effects, it is very difficult to treat these. So, once you develop this kind of effect, it actually is very difficult to treat. So, as a result they lead a more serious effect than the acute pollution effects generally, okay. And other feature is that they are not often confined to the small area, because chronic pollutants are such that, like if we talking about the pesticides available in the groundwater, so that groundwater will be consumed by so many people in that region, okay. The whole majority of these Bangladesh, majority of the West Bengal is basically the groundwater is contaminated with arsenic. So, if people are consuming that water, so large number of people actually are consuming, and some has more susceptibility, some has less. So, apparently some will get early effects, some will get later effects, but early effect also means 5-10 years. It is not that early effect means just by consuming water for a month or couple of months symptoms will start appearing. So, that way a large section of population might be at risk with these pollutants, because they are not often confined to a small area, okay, and they may go undetected for a long period. So, people do not even know that they are actually having certain effects of that. It is more that dangerous. So, for example, if you see this person starts drinking contaminated water from 1965, then by 70, 75 no apparent effect, by 80 it has started showing some effect here, and then by 90 he is in such a bad shape that it is hard to reverse. Okay. So, that way the chronic exposure is far more serious, but very difficult to detect and very difficult to control. Whereas the acute exposures, because the symptoms are appeared quite quite in a quite short span of time. So, it is easy to kind of detect that, check that and do the proper treatment. Of course, if the dose is so high in case of acute exposure that it is a fatal, it is like if you consume a water with very high level of pesticides or something, and it is like then it becomes as good as poison. So, if you consume that much and you get to a kind of fatal impact or that kind of impact, then it is hard to reverse. But otherwise acute exposures, like we see that many of the waterborne diseases or diseases because of the contaminated water, diarrhea, dysentery, those kind of things are all curable. Okay. So, that can be treated and managed, but it is chronic exposure which is more difficult to detect and treat for. So, these are some of the ways through which basically we get exposed and what kind of effects it may have on us, these pollutants. So, that was all for this class, and in the next class we will be talking about the assessment of water quality and the water quality parameters, because so far we have been talking about the water is contaminated or polluted, but how we signify whether certain water is contaminated or not. So, that we will be discussing in the next class. See you then. Thank you for joining.